Hey everyone, hello. So today's topic is how we implemented Selenium Grid using Kubernetes, Docker, Traefik, and Helm. I call it DA Cubes within my company as a code name. And my name is Ragavan, and I'm a principal software engineering test in Expedia. Expedia is, we call it Expedia Group. Right now, it has lots of brands underneath like hotels.com, Trivago, Agencia, Hotwire, and so on and so forth. Just before the presentation, how many of you are using AWS or any form of cloud? Any experience with Kubernetes? Great. And yeah, so let's go. Sorry. Okay. So just to set the expectation, what you are going to get out of this session. So this session specifically is going to talk about how you can run your tests in a distributed fashion, and how we have built Selenium Grid using Kubernetes, so it serves lots of other use cases than the current running in your data center or in AWS, but pure EC2 instance. You might have an idea like, okay, I can use Selenium Grid for distributed testing. You might not know that you can use Kubernetes and this way. So this is like unknown. You might know to use Kubernetes, but you don't know how. So it's like a known unknown. So in either bucket you are in, I hope this will help you in some way. So I've presented this. I've worked on this like probably for 6 months on and off with other projects, and I presented this in Selenium Camp in Kyiv in Ukraine in last September. So what we have today, we have around 100 hubs running, and on a day-to-day basis we run around 90,000 UI tests, and we create and terminate around 400 EC2 nodes at the moment. This is nothing to do with Kubernetes, but this is how we are running at the moment, and we are successful. We can distribute our tests and run much faster, so it serves our purpose. But but we are moving away from like a monolithic app to microservices, and every one of our page is becoming a microservice app. So they all run on their own CI/CD pipeline. So these challenges, these new microservices and everything, it gives us new use cases, and new use cases gives us new challenges that our current distributed automation, that is also Selenium Grid based, but it's an open source called Selenium Grid Scaler. It gives us new challenges. So that's what I'm going to list the problems that our current Selenium Grid is not supporting. Even though it can auto scale, I can request my hub, hey, I'm going to run 200 tests. It could immediately create enough nodes to run those tests in parallel, fully in AWS. But still, these use cases are real challenges that it doesn't work. So here, one of them is, first problem is pure EC2 based container. Our current solution is pure EC2 based, which means even though we don't autoscale the hub, we autoscale the nodes. Someone has to go to service and say, hey, I want to have a medium hub that can take like 300 tests at the same time, and within 5 seconds they will get an IP address and an instance ID, and they can go and configure it in their job. And whenever they run the job will start the hub, request the hub saying, I'm going to run 200 tests. It will autoscale. Then you run the test, you terminate the node, you shut it down. So here, one part is you have to start your hub. It takes some time because it's pure EC2 box. It say 1 minute, 1.5 minutes, 2 minutes. Then you have to auto scale. You have to request the hub. The hub is intelligent enough, even though it's not just Selenium Grid. It's Selenium Grid Scaler. It's an open source. So when you request your hub, the hub will say, okay, you want to run 200 tests. I don't have the capacity. I'm going to build 20 boxes for you. I'm going to create 20 EC2 boxes. That also takes around 2 minutes, 2.5 minutes. And so that's what the problem number one. The second problem is, microservices. shift left, speed of feedback cycle, dynamic hub creation for each run. As I said, we are moving towards microservices, so individual page becoming separate apps instead of one big monolithic app. And teams are moving to shift left, as he said, which means they want to moving away from just running your CI/CD pipeline after everything is checked in. You keep running, deploying every time there's a new change. People even want to, if they have a branch in Git, they want to pass that through their CI/CD pipeline, deploy it to a temporary stack in AWS or in whatever cloud infrastructure, run their test, and make sure their changes are not breaking anything before they merge it. Right? For that, imagine there's a team with 5 or 10 engineers, and 5 of them are they want to run the same, the different branches through a CI/CD. There will be 5 instances of CI/CD running with different changes. And with our current approach, it wouldn't work because the hub is static. It's just you only have one hub, and we can't autoscale it. And also the speed of feedback cycle, like what was acceptable 2 years ago wasn't acceptable last year, and what was acceptable last year is not acceptable now, because people ask questions like there are technologies that can solve that problem. There are technologies that can improve 1 minute. Why don't we use it? And dynamic creation for each run, I'll talk about it. So this slide explains you the problem that we are facing now, and the next slide will show you. For example, this is one CI/CD pipeline, and this is one Git branch, and there are many branches, and all branches are going through running an instance of the CI/CD pipeline. It builds, it deploys to a temporary stack, run the test, and then they're going to merge the pull request. What if two engineers want to run their branch at the same time? I can't use one hub because their change is specific to Chrome version 74, or other person's change is specific to Firefox, or I want to be cost efficient as well. Like I don't want to just leave the hub running. I want to shut it down when I'm no longer using. That's one of the purpose of using cloud is use only when you need it and stop using when you don't. So I'm not going to use one Selenium hub for different branches, and because it's going to be unstable and I can't shut it down and terminate because I don't know when somebody's going to use it. So we came up with this approach so that this is the actual, the talk about the Kubernetes-based implementation. So every instance of the CI/CD will have its own hub, where you don't have to go to a self-service and create a hub. You can just say, request a Jenkins saying, I'm going to run 200 tests. Give me a Selenium grid, the whole thing. It'll actually give you can name your grid anything, like your Git hash or anything, and then over your pull request. Each instance will have its own grid hub, Selenium grid. You run it, you terminate it because it's container-based. And this is the way our solution works. The problem 3 is multiple AWS account. For example, you have normally every company will have one account for test, one for prod, probably one for stage. Everything works fine. You can even expose your private IP address to your corporate network, your Jenkins infrastructure. Everything is fine. But when you go to multiple accounts, then the private IP address cannot be exposed from every account because they are reusable. That's the whole point of, and how you're going to make your hub URL accessible to others in different accounts, especially when you have a shared CI/CD infrastructure. So that is another problem, and that is why we used something called Traefik. It's a reverse proxy. And problem 4 is cost as well. When I use EC2 instance, PO EC2 for Selenium Grid and nodes and hub, I can choose a particular box saying that, okay, this box C5X large can run 10 Chrome instances. It can run 10 Firefox instances, but I cannot 100% or 95% use it, guarantee that every resource in that box is going to be used. I can say 95% of CPU will be used, but only 80% of memory will be used. I'm wasting 20% of memory or probably 50% of memory. That's the lowest you can fine tune at a particular EC2 instance. We want to fine tune at millisecond level. I want to allocate only 225 milliseconds for one browser running in one pod. Or I want to allocate only 750 meg for one browser or one Firefox. So this is the point. Some parameters are overly allocated when you just use EC2 instead of containers. Problem 5, for some of the solution, from 1 to 5, we have to use Traefik for getting external traffic into the Kubernetes cluster. It's a reverse proxy, and we will see how that works as well. So the solution we came up with is Kubernetes. Kubernetes is for automating deployment, scaling, management of containers application. So specifically, we implemented in EKS, which is Amazon cluster. And obviously, I'm sure everyone knows what Docker is. The interesting thing, what we use here is Traefik, but before that, Helm chart. That's where you mention what's your definition of your pod. It's basically chart is a type of package that Helm uses, and you can mention how many instances you want and whatnot. And Traefik is a reverse proxy. A regular proxy is your regular proxy is your clients will not know which server they are. Sorry, your servers will not know who the clients are. A reverse proxy is, Traefik is a reverse proxy. The clients, they won't know which server they are hitting. And that's the main difference. And Traefik is one of them. You have Nginx, but we use Traefik. So this is how the general architecture of Kubernetes. You have Kubernetes master. Normally, it's on the AWS management side, and the node, which is normally an EC2 instance on which the pods and everything runs, will be on your account side. etcd is basically it makes sure that there's no resource starvation, and every EC2 worker node in Kubernetes will have two processes running. One is kubelet and proxy. Kubelets make sure that your pod is running fine as per the expectation. Proxy is for request redirection, and a pod is basically the smallest unit in Kubernetes. If it wants to restart something, then it restarts the pod. It doesn't restart individual containers within the pod. You can have one container inside a pod or more than one, but normally the acceptable or the best practice is to run one container within a pod. And then you can see here, there are two EC2 nodes, and each running kubelet and proxy, and each running two pods. And within that, there are two containers, one running Firefox and Chrome. And this is just the general setup that looks like. Sorry. So because the other topics are, I'm sure many people know about it. The Traefik is the most asked. So I just want to touch base on that. There are different ways to get into external traffic into your EKS cluster. For example, when you have a hub and you have a URL, which is private IP address, how do you point that hub to your automation so that whenever your automation runs, it actually hit the hub and hub load balance and your test runs in parallel? There are different ways to do that, but the professional or the reusable and the right way is to use an ingress, and Traefik is an ingress. It's a type of ingress. And this is the big picture looks like, end-to-end flow. Your regular traffic comes, and for example, I have a hub called hub demo 2, hub demo 1, hub demo 3. I hit it, I point my automation to it. Kubernetes has a concept of service. A service is something which manages a group of pods based on a label, some kind of grouping. So the ingress rule, I would say that I've hard-coded here, but normally it's templatized. So it says that if the request coming from hub demo 3, blah, 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 send all the requests to the service names hub demo 3 Selenium hub. So it will go there, and the service will send it to a hub, and hub will load balance it, the test, and then send it back. So I can create any number of hubs with different domain names, and I can truly believe that my Ingress rule will make sure that when I hit a particular hub, it goes to the right pod and it hit the right browser version. So pictorially, to say that the 3 hubs, the hub is actually a pod, and then for example here there are 3 browsers, though that means 3 pods, totally 4 pods running in one EC2 instance. Autoscaling. What type of autoscaling available in Kubernetes? So you can, generally you can autoscale horizontally or vertically. Like for example, if you can run only 10 browsers in C5X large in AWS, you can increase the size and run more browsers. Or you can scale that and run many browsers in different boxes. So here, horizontal autoscaling is increase the number of nodes or increase the number of pods. Vertical is you increasing the size of the node or increasing the size of the pod. But this is not recommended. This is the best approach. The reason I've striked auto is what I'm going to talk about is scaling first. So this is the command. I have put everything in my Git repository so you can actually see the whole thing. So if I say Helm install Chrome, I enable Chrome pod and give the name of the directory where the Selenium Helm chart is, and give the name for my release, and point it to my config, which is pointing to my EKS cluster, then I'll get a hub immediately because it's container. If your worker nodes are warm, then you will immediately get it within 30 seconds. Then I will say Helm upgrade and say I want to scale the number of nodes to 50 and say Chrome replica. Immediately I will get 30 nodes attached to my hub. And I can say I'm done with my automation, delete it, and it will be immediately gone. And this is a pictorial representation of how I'm thinking it will be used in a microservice world where you can just create hubs on demand, run your tests, and destroy it. So horizontal pod autoscaler is real autoscaling based on observed CPU utilization. So for example, this is not scaling, this is autoscaling, where you can actually tell the cluster that if the CPU exceeds 90%, you can scale the pods all the way up to 10. So this is right now I'm not using this at the moment. I'm only using scaling, not autoscaling. And you need to run the metric server to make this work because that's the one is going to provide the CPU and memory metrics. So this is just an example. What happens when I say, create a Selenium grid? What happens? By default, you will have at least one worker node, which is a plain EC2 instance, whatever type it is you specified, running some important services. It will create a hub pod. Whatever is the default configuration in your Helm chart, it will also create one pod that is running a Chrome or Firefox container. Now, when you say scale it, when you say Chrome replica 35, the first thing that's going to happen is the Kubernetes cluster is going to scale your worker node because it's going to say, oh, I've got a request to create 35 pod, but I don't have enough underlying hardware or virtual boxes to run those pods. It will actually scale the worker node and then create the pods. So these pods are running on plain EC2 boxes that are called worker nodes. And when I'm done with my automation, I'll say delete, and the pods will be gone. And once the pods are deleted, the worker nodes will also scale down. And that's how you make sure that you pay only for what you use. Sometimes when you are starting and only one project is using, when this happens, when you're running automation, every time say, probably you're running only once a day or something like that, or you are the only team using it, the worker node is not going to be warm, which means there's not going to be worker node when you actually need it. So when you say, I want to run 200 tests, there's not going to be worker node, and you have to wait for the worker node to be created and then pod to be created on top of it. So for that, their workaround is you can have, I want to have minimum 10 worker node all the time. It is going to cost you because they're going to be running all the time, even though whenever it's not necessary. But it will increase the speed at which you create the grid. HTTPS-based hub. So I'm just sharing some of the learning because when you use Traefik, your hub will be HTTPS based. So we found some issues trying to run automation against HTTPS based hub. For example, we had to change our Nitro.js, some configuration here so that we can run against HTTPS hub. We couldn't run it using our Scala test framework. We had to upgrade to, I think, latest train on 3.x in Selenium WebDriver version. And it worked, but it's just sharing. This is also important, especially when you want to have a reliable grid. Kubernetes has a concept of QoS, quality of service. It has guaranteed, burstable, best effort. Forget about the other two, but what you're interested is guaranteed, which means you want to have your grid a more stable one. Right? You don't want your node to be just terminated by Kubernetes because of lack of resources. So when you specify resources under request and limits exactly the same amount, then Kubernetes consider for that kind of pod, it always guarantee the quality of service, which means these pods will be the last one to be terminated in case of lack of resources. So always make sure that your pods have QoS as guaranteed, and that's how you make it guaranteed. For example, if I remove limits, then my pod will not have guaranteed. It might have best effort. So how you give that the combination determines what type of QoS you're going to get. I tried running multiple browsers in a pod, one browser in a pod. I think running one browser in a pod is most cost effective, so you can make sure that, and also more stable. And this is some numbers. I wanted to convey a message to people who are developing core committers, because when I started with Selenium Grid Scaler concept, implementing that the open source one, I was able to run 15 Firefox and 15 Chrome on C5X large. 15 Firefox and 10 Chrome, because Chrome had always the Chrome WebDriver running with every instance of Chrome. But Firefox didn't have that earlier. And then once the Gecko driver came in for Firefox, this is how much I was able to run on one C5X large. And after Kubernetes, because there are additional pods running in every node, even that has reduced to 8 per work node. But it doesn't mean that it is not cost effective. You can try different type of boxes and see which one suits your need. There is a myth about headless browser. Like, people think like it's fast. Even I hear famous companies providing or marketing saying we are giving headless browser. This is my experience. Correct me if I'm wrong. When you run an automation, a single test on a regular browser or on a headless browser, like Chrome headless browser specifically, I don't see any difference in the execution time. The only benefit you get for running in a headless browser is if you're running locally on your laptop, you don't see the browsers. It's running on memory, and you can actually carry on with your work. So, and only benefit you see is when I deploy a headless browser as a pod, I can disable the XVFB process, which probably saves like few milliseconds of CPU cycles. This is really an important thing. I'm sure if you keep this in mind, you will definitely appreciate me, because I came across this. I learned this hard way. I was trying to stress test my solution. I was trying to run like 300 tests, 400 tests, and suddenly I saw that nothing was getting created, because by default, Kubernetes allocate a certain number of private IP address per worker node, whether that worker node is running any pod or not. If you have a worker node like EC2 box, C5X large or whatever, Amazon has a number for that, the number of private IP address that is supported on that box, and that will be immediately taken away from your free pool of private IP address. The problem is, imagine you know that you can only run 5 of your application, any type of application, 5 pod or 5 instances of your application as 5 pods in C5X large. But if Kubernetes is going to reserve 25 private IP address for that box, you're going to waste 20 IP address per box, and you will soon run out of IP address, private IP address. If you're on a shared environment, you will bleed to death. Like, you won't have IP address because it's just using unnecessarily. So the way you can configure it is, so there is you have to deploy this, and there's an environment variable called WarmIP Target, and you can configure it based on how many pods of your application you can run on your whatever type of box. Then you can set that, which means now it is tied to that amount of private IP and not the default one. Yeah, this is the default one. By default, you won't have these configuration in the Selenium Helm chart. You need to add it. Without this, your Firefox pod will not run and work properly. And I had some of slide, but I was told I have to limit my talk to like 20 minutes, 25 minutes. I shortened it, but if you want the full version, it's in YouTube, what I presented in Selenium Camp in Kyiv. So you can actually take a look. Thank you very much.